Good morning, ladies and gentlemen, and welcome back to the JEC World Live demonstration area. We are very pleased to welcome back for the last time Magnum Venus Products. MVP is a global manufacturer of fluid movement and production solutions for industrial applications in composite and adhesive markets. Charles Tur is a renowned specialist in resin transfer molding and infusion technology. Charles is going to show us how traditional LRTM molds can be transferred to achieve rapid injection times and elevate the quality of your molded parts. Charles, the demonstration floor is yours. Over to you.
Thank you, Joanna. So I have to explain. She said for the last time this year. We'll be here next year. OK, so welcome, everyone. Thank you to be here on the last day. So we would like to introduce a process that we already introduced the previous year, but we optimize it. So Fast Flow LRTM is a combination of light RTM and silicone bag. The idea is to optimize production. When we focus on production, what we want something easy to load the glass, fast to inject, easy to demold, and no trimming. We would like to demold a direct finished part. Also, we would like that when we demold it, the mold is clean. We don't want to see people scratching the surface of the mold or the technical trench and so on. So we put everything together, and we get that. Also, we find that customers want sometimes to produce part with filled resin. The problem of the filled resin is a little bit more complicated for the resin to flow. And when the distance of the resin flow is too long, we have what we call filtration. So the fiberglass retains a little bit the filler, so you don't have the same properties on the part. So when you have a rigid countermold, the main advantage is that the rigid countermold will push down the glass on the corner, which a silicone bag don't do. But if you use a rigid countermold, you have to inject the resin all around on the resin channel. That means when you demold the part, you have to trim out the resin channel. Now, you can use the silicone bag, where we do introduce what we call the collapsible resin channel. So we inject the resin in the center, and the resin will flow to the border. On the border, we can stop precisely the resin. So then we can make a finished part. What we have developed here is a combination of both. We find a way to laminate composite on the top of the silicone membrane, and it bonds together. So the part we demonstrate today is a part of transformation, but it works for any different things. We have run some tests that was 2 years ago with a PU resin, which has a viscosity of 800 centipoise. Now, we make a glass table test, and we see the resin flow, and we find that it takes 4 minutes for the resin to flow 30 centimeters. But if we try to reach 80 centimeters, it takes more than 20 minutes. Why? Because it's a high viscosity. We want to go fast. I'm going to inject this part in 2 minutes. So for that, we have to review our way to inject the part. If I have a light RTM mold, for example, 5 square meters, if I inject the resin all around on the resin channel, we will have a maximum distance of 80 centimeters, and then it will take approximately 20 minutes to inject the part, which is too long. Now, imagine that because we use the collapsible channel, we'll not see it, then we increase the quantity of the resin channel, decreasing at the same time the resin flow distance. So here, the resin flow distance for 5 square meter part, will be maximum 30 centimeters. Then we are able to inject the part in less than 4 minutes with 800 centipoise resin. You can see what happened. Here we do that on the glass table. You inject, the resin go everywhere on the resin channel, and then fill the part very quickly. Collapsible resin channel is working like that. You have a mold where you load the glass, the gel coat and the glass, as you like. Then you put the bag or the countermold on the top of that. You apply the vacuum. And then you apply a second vacuum into the resin channel. At this time, the resin channel collapses. Then you have a free line to introduce the resin. The resin will flow where it's easy to flow, means on the resin channel, and then will flow into the glass. Like that. Then when the right quantity of resin is injected, not when the part is completely filled, but when you have injected the right quantity of resin, which is easy to determine with our injection machine. We have security, predeterminating counter, and so on. We inject the part. We have to consider that the extra quantity of resin we have on the resin channel will finish to fill the part. So the only thing we have to do when we stop to inject is to stop pulling vacuum on the resin channel, and the membrane will come back flat. You will not be able to tell how we inject the part. And at this time, we finish to fill the part with the excess of resin. So then, to build the counter mold, we calibrate a part thickness. That can be done with sheet wax, or we can inject the part. We use ceramic, which is perfect and reusable. Then we set up the technical flange like if we build a light RTM mold, except that we don't need the resin channel. Then the first thing we do, instead to apply a gel coat to build the counter mold, is to spray silicone to build the silicone bag. And we load the resin channel according to the time we want to inject the part. So we decide about the resin channel network before. And on the top of that, we are able to laminate composite and that bond. There is a trick. We will show you that. It's very basic and very simple. So now you have on the top the counter mold. And then when you apply the vacuum on the resin channel, you can see how it's working. So we load the glass. We put some resin stopper. We close the mold. And in this case, we have only one vacuum. It's the same vacuum to close the mold and to assist the resin flow. Very, very simple. We have an injection valve in the center, and we inject the resin. So just one detail. We have a collapsible channel. We have the injection valve. We have the air signal coming from the machine when we start to inject. That provides air to open the valve and to open the vacuum valve. In this case, we collapse the resin channel. We inject the resin. We finish to inject. The machine will stop. Stop to send the air signal. The valve will close. And the vacuum valve will close. But to close the vacuum valve is not good enough. You need to have the air coming back into the collapsible channel for him to go back on the right position. That's why that specific valve stops the vacuum, close the vacuum to be sure that we don't lose vacuum on the vacuum pump, but let the air passing through for the collapsible channel to come back. We focus on security. If you have that on your mold, people will never forget to remove the vacuum. If not, it will be full of resin channel, which is not good. And then you flush the machine with the acetone, and you flush the valve at the same time. So you will see that when we demold the part, there is no visible resin channel, no excess of resin, no waste, and so on and so on. So now let me show you how it's working and what we improve here. What we improve here is that we work with skin mold. So see what we are going to do now on different customer. This is a 6 square meter part. We organize the infusion strategy. We build the mold, which is a rigid mold with silicone on the surface. We close, we inject the part, and we demold the part. Easy, 5-minute injection time. And we can do many different part shape working like that. So here's the mold we have done, and the part we inject after that. You can see the resin channel networks, and that's the part demolding. Then we can, there is no limit. There is no limit on that. See the counter mold with the resin channel. Here we are in USA, for example. So we build a silicone bag. We laminate the composite on the top of it. We spray gel coat. We load the injection mat. We inject the part. We demold. What is very important for us is that when you demold the part, you demold a finished part, even the hole in the middle. And when you demold your mold, your counter mold on the back is clean, and your female mold is clean. Nobody work scratching anything. Okay? So since we are able to decrease resin flow distance as needed, we are able to use a higher glass content or higher resin viscosity than normal closed-end mold process, having low injection pressure. The resin will not flow more than 30 centimeters, which is almost no pressure on the mold. Now, what is the change, what we have done? If we are able to inject fast, if you inject that part in 2 minutes, we can have like 3 or 4 minute gel time. It means after 10 minutes, we can demold the countermold. But we don't necessarily want to demold the part. We would like to leave the part on the mold. The point is, if you leave the part on the mold is blocked. You cannot inject anymore, except if you use what we call skin mold. So let me show you what is skin mold. We have a mold here. I simulate, huh? I don't inject that part yesterday. I just put an injected part for you to see it. So we have a skin mold. I have injected my part. I don't want to demold the part. So I leave the part inside the skin. That skin is an injection part, and I'm going to show you how we do. Here, I have already a part ready, gel coat, fiberglass, and so on. My mold is free. I put the skin inside. I close my mold, and I inject the part. It's so simple like that. And the cost of the skin mold is very, very cheap. It's just a skin. So you inject the skin on the mold, that's it. So you can have 10 like that, and you can produce every 10 minutes, you can make a part. That's for high production. So we inject fast, we demold fast, and we put a skin on the mold. So now if I look at the countermold itself, may you remove the... Here. Hello. That one here. Thank you. Pull the mold like that, and just keep it like that. So here you have the surface of the mold. And now, if I apply the vacuum on the resin channel, you have the design of your resin channel. So I will introduce the resin here. The resin will flow. The resin will flow very quick on the resin channel, will flow in that direction, and will flow here. The maximum distance for the resin to flow is that. So in 2 minutes, I inject the part. Then the silicone will touch the surface. I design my mold to be sure that the people will know exactly where to stop the glass. So then, when I demold the part, I demold a finished part that don't need to be trimmed. What I do, I just grind a little bit here, and it's done. That's it. And my mold is clean. And here, you have the step to stop the glass. And here, so people in production cannot make mistakes. They know exactly what to do. The full process is focused on production. So now, when I stop the vacuum, this is what happened. The channel come back. So I will just connect the thing properly on the back, just to be sure that everything is working properly. I will turn the mold back. Hop. I will close the mold. Then I apply the vacuum here. Okay? Here I have a resin stopper, which is a peel ply. Why? Because it's very easy to remove. I close my mold. I apply the vacuum. It's closed, and that's it. Now the only thing I have to do is to inject the part. So to inject the part, I have the injection machine. You want to say something about the injection machine? No? Okay, no problem. Next time, okay? You will come back. We'll explain everything. So that injection machine has security that we call MPG. We'll mix catalyst and resin here. And here we can predeterminating the quantity of the resin we are going to inject. We have gel alarm and so on. So it's a configuration, standard configuration at MVP where we focus on security and production. So I put that here. And now I'm ready to inject the part. So I inject the part. I start up. The resin has to flow that distance, so it can be very fast. Now I have nothing to do, so I can go to work to set up my skin or to do anything. The machine will stop. So here we already inject 25% of the resin we have to inject. Don't try to see anything, you see nothing. Countermold is closed, there is resin and composite, so I'm sorry. It's not very attractive, but it works. So we have injected already half, 1 minute. And now just the resin flow first on the resin channel because I create the pressure, and now it's moving on box side. Voila, 80%, 85, 90, 5 stroke more, 1, 2, 3, 4, down. Part is finished, part is injected. The only thing I have to do now is to flush the machine. I cannot forget. If you forget to flush the machine, we have a security on the machine. It's a whistle, it's an alarm to remember, hey, you have to clean me. If you don't clean the machine, don't worry, we sell spare part, new machine and so on, no problem. So you flush here. The acetone clean the machine, come into the valve, clean the valve. Nothing to do. You don't have to use a jacket to work with, but you can, it's clean. This is what we expect from the system. So now, it's done. So we'll put the skin here, if you don't mind. Like that is not in the middle. And voila. So now I can set up my next one, and 10 minutes I demold, and I put this one in. It's very simple, and I can have 5 like that, 10 like that. The cost of that is very low price. Let me show you how it works, because we need to understand how we build it. You have to ask the question, hey? So, is a skin that we load inside the glass. We load the glass inside the skin, sorry, and we load the skin inside the mold. Alors, to explain that is, thank you, a question. Please, sir. D'accord, okay. So the question is, why do you have a rigid contour mold instead of the bag? If you inject too fast on the silicone bag, you will blow up the silicone bag. If it's rigid, it will accept more pressure. So if I just use the silicone bag, I have infusion. If I use the contour mold, I have injection. The difference between both of it is 2 or 3 minutes, that's it. No more. But both work. So first, you build the pattern. Some people CNC the pattern, some people make the pattern, doesn't matter. Remember, on the pattern, you have to make the step on the part border. Like that, the people know where to load the glass precisely. On that, you make ready your mold. I used to have vertical flange outside of the mold. Like that, when the people arrive with the glass, they don't stretch the glass on the border. Doesn't matter. Then, on the pattern, we laminate a mold. Okay? We laminate a female mold. We reinforce it, so for that we use gel coat, vinyl ester, skin coat vinyl ester, and low profile tuning resin. We put the metal structure, we demold the mold. Then, when we have the female mold, we copy the female mold. First for the security, in case you want to make more female mold, and then to be able to produce the skin mold. So we make the border, we come and we laminate, and we get what we call a mold pattern. Okay? And we demold it. So now we have 2. We have female and male. That male has no calibration. It's exactly the copy of the female. It's like your pattern. Then, when you have it, you have that female mold pattern, and then the male mold pattern, both of it. On both of it, you have to make a calibration. You calibrate on the female mold, on the contour mold, the skin mold thickness. You calibrate that thickness. Okay? The thickness of that, which is not necessarily the same thickness of the part you want to produce. A skin mold is something like 5 millimeters. A part can be 2, 3 millimeters, doesn't matter. We do that, as I explained, with Soric. Then on the female mold, we calibrate the part thickness. So you see the difference. Then on the top of that, as I explained, we can make it by Soric material. You can grind it and get a smooth surface, which is nice, easy to do, and it's permanent. We have now a spray filler. We use the one from Aroma, which is fantastic. You spray, you sand, you even are able to polish. So you have your female mold pattern. You have made your calibration. Then you set up your seal on the border, on the flange, and then you laminate your contour mold, your final contour mold, the one I use here. That is on the female. On the other side, you remove the calibration, and you have your countermold ready, where you will put the wing seal and the dynamic seal. On the other side, you have calibrate your skin mold thickness. Then you laminate your final female mold, which is this one. This one ready to receive the skin mold. Okay? So you have the counter mold, you have that. Now, when you have the mold pattern and the female mold, you remove your calibration. Then you come to apply your gel coat, you load the glass, you put back the mold, and you just inject or infuse your skin mold. That's it. It's so simple like that. And then, after it, you demold your skin mold. You don't forget to put wax on it. And your skin mold will be ready for the production. So that's the production of the skin mold. So you can see completely on the right pictures the skin mold. Then you load your skin mold. You load the skin into the female mold already with the fiberglass and the gel coat. You come with your counter mold after you put your resin stopper. You pull the vacuum to close the mold, which is the same to assist the resin flow, and you inject the part as I have done on the front of you. That's it. So the investment is not huge. What is the true development on that? The development is not the system. That system exists 25 years ago. We renew the system to make it easy for the people to produce their own mold. And that is the true development. And then we close and we inject the part. And the resin will stop exactly on the part border. And voila. And you get your skin and your part when you demold. Okay? You understand everything, or I start again? We don't care. We are on lunchtime. The next demo is at 2 o'clock. We have plenty of time. So, I don't know why I have it twice. I will come back. Yeah, so what do? We organize training at MVP. MVP is a machine producer. We produce all the machines for the composite industry. And we have a closed mold division where we have developed things helping customers to move up on production. If you move up on production, you will need more machine, and this is what we sell. So everybody happy. So we travel around the world. Here, for example, that was a training in Egypt, where the customer wanted silicone bag. He wanted also produce the sandwich doors, but also light RTM. So we did it with them. We teach them how to make the mold, how to make the counter mold, and to inject the parts. We do training for our distributor, because according to the country you are, so we want to be sure that our distributor will be on the level, on the technical level, to help you. So that are the first people we train. And then we have 2 training centers, one in the south of France, near Perpignan, where I'm based, where we do receive customer, distributor, but also suppliers, because we have plenty of suppliers who come to us to ask what we think about the product, and we also develop with some suppliers specific product, like the development for silicone or any other product. And we have another training center in USA, in Knoxville, Tennessee. Our next training will be in Tennessee the 2nd week of April. Tennessee is a nice place, and they have a good whiskey, just for the information. So thank you very much. We would like to thank Pauline to give us the resin. Owens Corning, which is the injection mat that I have used here. And Owens Corning have a full range of fiber for closed mold. I use a special one also when I make the skin mold, which is a full glass injection mat, which is perfect also for that application. Then, because it's the last demo of that year, we would like to thank you very much, the GC Demo Zone team. It's a big job to organize everything, and you have all these people here who follow, organize the video. We communicate together because that optimizes the quality of the demo. So thank you very much, guys. Always a pleasure to work with you. Thank you very much, and see you next year. Bye-bye.
So thank you so much, Charles. Ladies and gentlemen, please feel free to come to ask any questions to Charles and to the MVP team, or to visit them at their stand at 5U58. It's been a pleasure, Charles, to have you here once again this year, and we look forward to welcome you again next year. Ladies and gentlemen, our next demonstration will take place at 2 o'clock with Thermwood. So if you can, please come back and see Thermwood and their LSM system. Otherwise, we wish you a fantastic day at the JEC World.